Very good.
Nice.
We're live on YouTube on the God Foundation channel. This is Architectural Education Now. I'm Gokhan Karakus. I'm a designer and critic based in Istanbul, and today we will have the opportunity to speak to another important architectural educator, architect, and also somebody that is coming from the Istanbul Turkish architecture culture, Elif Erdine. Elif, thank you for joining us again, or joining us.
Thank you for having me. Thank you for having me.
So just quickly, this Architectural Education Now series, we started off about a couple of months ago in the midst, at the beginning of the coronavirus situation, as a way to kind of assess what architecture schools are doing with their education. Architecture is a discipline which requires physical contact. You have to go to places, look at things, talk to people. So we tried to figure out what was going on. So we talked to first Winka Dubeldum of the Weitzman School of Design at the University of Pennsylvania. She's the chairperson. And then we talked to Shulan Kolatan of Pratt, who is an old professor of mine and still a colleague of Cole Mack in New York. And today we have Elif Erdine. And we'll talk about architectural education now from Elif's perspective, which is a little bit different perspective, because it's not just architecture education during the school year, but she also has initiated and has been the leader of a bunch of summer initiatives. Okay, so Elif Erdine is a 2003 graduate of the Istanbul Technical University School of Architecture, Faculty of Architecture, graduating top 300 class there, so very successful tenure there. And then she moved on to the Architectural Association in London and received her master's at the Design Research Laboratory in 2006. From 2006 to 2010, she worked at the MTech. 2010, she started leading the efforts of the AA Visiting School and the Summer D Lab. And some of those efforts were here in Istanbul. And 2015, she got her PhD at the AA, and 2019, last year, she was named the director of the Emergent Technologies and Design graduate program. Okay, so Elif has a long list of successes, and but the important part here, I think, is, you know, you're and you're going to explain to us now your particular materialistic, material-oriented, process-oriented approach. Want to talk a little bit about that, and then in terms of technology, what you're doing. So let me shoot it over to you. Elif is joining us from London, by the way, from her house.
Yes.
And we're here. Okay, so Elif, ready.
Thank you, Gokhan, first of all, for the introduction. And thank you to God Foundation as well for having me be part of this series. I think it's really important to be discussing the state of architectural education, you know, during COVID and post-COVID. And as I will be explaining now, particularly programs where, like mine, where we do a lot of material research and a lot of like hands-on experiments, I think it's really important to think about, you know, where the School of Architecture stands and where we educators stand, you know, in terms of reaching out to students and in terms of carrying out research, basically. So, as Gokhan said, I'm going to start sharing my screen now, and I will be showing you some of the work that we've been developing as part of MTech, but also as part of the visiting schools that I've been running. Just give me a moment, please. Sure.
At the bottom.
Let me know if you see it.
Yeah. Okay. Okay, we can see it. Yep.
Perfect. Okay. Great. So like I said, I'll be talking a little bit about the work of MTech and the visiting schools that I've been running. MTech is, one second. Yes. So MTech, Emerging Technologies and Design, is a postgraduate program, and we offer Master of Science and Master of Architecture degrees. The program was founded in 2001 by Dr. Michael Weinstock. He's still serving as the founding director of the program. And we are very much interested in the, let's say, in the associations between physical prototyping, material experimentation, and computational form finding and analysis. So I'll just kind of go through some of the simple examples. These are all student work, obviously. Some examples of the work in our studio. So this work that I've been showing right now is part of, what the students start to experiment with when they join the studio in the beginning of the term. And what we are really interested in is basically to kind of bridge the gap between computational form finding and analysis tools, as well as physical making, prototyping, and robotic fabrication tools. I personally am very much interested in robotic fabrication for design. And some of the work that I will show also reflects that. I think that this slide, if you can see on the left-hand side a computational model, and on the right-hand side the physical output of that computational model that is basically overlaid with the computational model itself. And I think this kind of really overlines our approach in a really good way, because we are very much interested in the feedback between computation and making. So we do not see computation as a means to an end. It's a tool for us. And what is really important for us is to really analyze what comes out as a physical model and how that corresponds to the computational model itself, and how that physical output can become, again, a feedback mechanism for the computational kind of systems that we are developing. So these are some of the, sorry about the sound, let me just turn this off. This is some of the work that we've been developing in Istanbul. Actually, I'd like to give some brief overview of what we do in these visiting schools. These are very short but very intense educational programs. They usually last for 2 to 3 weeks. Sorry, 1 second. I'll just, yep, 1 second. Sorry about that. Yeah. These are very short programs, like I said, very intense programs. And the idea is to give the participants an overview of, what is going on in the world of architectural technology and computation. And technology pertains to obviously both digital and physical technologies, and how we can use these technologies as a means for, innovation and design. What I tend to do in each of these programs is that every cycle has a basic research agenda, and that research agenda deals with material properties, fabrication techniques, and various combination of those basically. And at the end of each cycle, we like to publish papers on either journals or conferences, so on and so forth. So we really care about the innovation part in terms of research. Now, when it comes to the educational part, we are very interested in creating this kind of atelier or like studio environment, where both us as tutors and students are part of like a big collective, And for me, it's really important to state that, students learn from tutors learn from students. So it's a really collaborative, democratic environment. We do not treat this as, okay, I'm your tutor and I'm teaching you this and that. No, there is a lot to learn from everybody. And this is the kind of environment that we like to emphasize and that we like to foster, basically. So these are some of, again, like I said, examples of our work from previous years. This is still Istanbul. In Istanbul, we have been working with GRC, shotcrete technology, and our industry sponsor has been Fibrobeton for the past 2 years. And we have developed some interesting research that we've been publishing for the past 2 years in different conferences.
And just to clarify, this is at Bilgi University, correct?
Yes, exactly. Yeah, I was just going to say this has been a collaboration with Bilgi University. Now, moving on to another project, again, dealing with robots. This robotic lab that you see right now is AA's satellite campus in Hook Park, Dorsey, and obviously they have huge robotic arms there. And in this workshop, we were focused on generating in situ robotic banding for a reinforced concrete structure. So, you know, obviously, both the automation part is very interesting, but, you know, beyond the automation part, it's the fact that through robots, we can customize a lot of these processes, and, you know, obviously it's much faster and, like I said, autonomous, but also there is the opportunity for customization. So just kind of, these are some images of the formwork that we had developed for that concrete structure. And the rods that you saw earlier on are placed within the concrete structure. And this is basically showing the concrete pouring process and then removing the entire formwork. And this is part of, again, the concrete pouring process. So as you can see, it's quite fun at the same time, also quite intense. And there's always something to learn with every step of the process. So everything needs to be designed, you know, in advance. We've also won several awards with some of these projects, these experimental prototypes. This is another material system, as you can see, timber. So this is part of MTech's history. MTech has a kind of a quite, let's say, old history of working with timber technologies. And we've had collaborations with firms such as Elif, Bureau Heppelt, ETH Zurich. And, you know, you take a simple material as timber and then start to experiment with how you can, let's say, bend it in different ways, what kind of openings you need to generate, you know. So it's quite an intense, like I said, research agenda for each of the material systems that we develop. And the last one I think that I'm going to show, I quite like this diagram, I must say, because this shows in a kind of an overview of the whole computational and physical workflow that we had developed. And, you know, it might be a bit maybe difficult to understand, but what it's trying to show is that, you know, we work in different scales, both like local component scale, global system scale, form finding scale. There's a lot of analysis going on, in this case, finite element analysis. And what's important is how that analysis then feeds back into the form finding process. So there's always these loops that we need to design and consider. So in a way, the architect becomes, you know, the system designer, so to speak. And I find that quite interesting. And, you know, every time we start you know, students start with very simple material experiments such as these, but it's a lot to do with, it has to do with documentation, understanding, you know, geometrical principles, mathematical principles, and then starting to kind of simulate those principles in very simple scales. And then kind of extracting those let's say, mathematical principles and moving on to more kind of global, let's say, form finding. I will not keep it very long, and I will not go into too much detail. But what I'm trying to show is that it's a collective effort that, you know, needs to be kind of kept ongoing in all scales of the experimentation process. So yeah, these are different examples from that experiment process, analysis. And again, as you can see, it goes back and forth between like the local scale and the global scale. And of course, at some point, there's a lot of making that starts to kind of come into place that you will see shortly. So all of these simulations have a meaning. It's for us to test if the actual experiment is going to work or not, obviously. And then, you know, even if you run accurate simulations, there's always that something, there will always be something that goes wrong. So then you can go back to the simulation, change the parameters, and, you know, run it again. So it's very iterative in nature, I would say. So these are some of the joint experiments that we had developed. Yeah. So all custom joints in this case that were kind of resin cast. And, you know, I also find this quite kind of interesting because, you know, with the tools that we have right now, everything is becoming really extremely accurate. And, you know, one needs to start thinking when our digital models are so accurate, you know, but then you have people that are putting these things together and there will always be some kind of human error. How do you kind of compensate between that kind of high level of accuracy, precision, and human error? I think that's a very interesting kind of topic to think about as well. And that human error really comes into place when you kind of go into this, you know, assembly process where, you know, everything is flexible and moving, and there is no way that, you know, there won't be any error. So then, of course, you need to really evaluate the finished product and understand, you know, what went wrong, let's say, what were the challenging bits, and how they can be corrected the next time. So that's also what I mean when I say iterative. But, you know, this is part of the educational process. So it's a lot of learning through making, learning through experimentation, and, you know, you are not bound to the studio space. And, you know, education in this sense can take place anywhere, really. So just the final bits. These are some of the final shots of that prototype. This is the AA, by the way. It's the AA terrace. And what we did later on that was quite informative, actually. We did a 3D scan of the finished product, of the finished prototype, and overlaid it with the original digital model. So this is the 3D scan. And the next slide that you will see here, the point cloud that you see in this slide is the actual finished product. So you can clearly see the areas that have deflection. So this gives us an opportunity to understand how the structure, you know, performed, or which areas it failed. And that's why, you know, I keep saying it's iterative, so that next time we have a better understanding of, you know, how to approach the design problem, basically. And so that's it from me right now. I think, I mean, I try to keep it very brief. I hope it wasn't too fast or slow. And if that's okay, I'll stop sharing my screen.
Yes.
Yes.
I just want to just go back to that last slide. I think it was interesting, and you mentioned it between its accuracy and.
Sure. 1 second. Did I stop my screen or?
Yeah, you stopped it, but.
Okay, I'll start it again.
I'll ask a question. When the whole process of digitalization started in architecture, in terms of a three-dimensional model, let's say 20, 30 years ago, I mean, there was this. The mathematical accuracy was something that drew a lot of people to this, because we created these very elaborate geometries, you know. As it's kind of been going along, those elaborate geometries have sort of been replaced by much more modular geometries, like the ones we've seen here. So that design geometric purity has been kind of lost. This latest series in terms of 3D scanning, and then is the objective here to make it more accurate, or is the objective in terms of this feed talking about to perhaps put in more of an inaccuracy? What do you think the direction as regarding this point is going? What do you feel like is the direction for this?
I think the direction is to document the inaccuracies, first of all. It's also, I mean, if we take this as a specific case, in this case, we realize that, for example, the joints were not strong enough. And so for us, it was a way of documenting the inaccuracies, but also understanding, you know, how we can improve, in this case, for example, the material system that we use for the joints, so that they can perform better next time. But also what you say is very interesting, because there is this discrepancy between, you know, too much accuracy and the, you know, inaccuracies that you get. And, you know, you will always get some kind of inaccuracies when you build something of this size. So I think that first of all is documenting inaccuracies, but also it's really understanding how you can improve it next time, you know.
It's a feedback to that.
Yeah, exactly.
Both form finding, but also the prototyping.
Yeah.
Just to kind of go back a little bit, so you and your both educational experience and in your architectural experience had the opportunity to work in really centers for this kind of thought and architecture starting in 2000s to late 2000s, 2010s. Yeah. And focusing a little bit on architectural education, the students that you've had in the last few years, I'm curious, what have they gone on to do? Because what you're presenting here, what goes on in the AA, is sort of advanced, very advanced research and design.
Yeah.
And when these students go back or try to find jobs, are they finding jobs in this area? Are there more positions opening up for this kind of design, technology, prototyping research, or are they having to kind of, I don't want to use this word, I'm going to use this crude word, but are they having to dumb themselves down and sit in the office and AutoCAD and figure out? I mean, what's the dynamic between the graduates and where have they gone?
I mean, okay, like as you say, I mean this postgraduate program, and there are also a couple of others at the AA. These are very specialized programs, like you've said. So what happens when after our students graduate? I mean, first of all, I must say London is really thriving, not at this very moment because of the virus, but in general, London is really thriving in terms of like these research groups, research teams that have been forming in offices. So a lot of big offices right now are forming their in-house research and computation teams. Of course, Zaha has had it for many years. I mean, Zaha was the first to actually have this kind of computational team. But offices such as, Heatherwick, Brydenwood, Buro Happold, Arab, I mean, you name it. A lot of offices are having these in-house research groups now. So some of our students join those research groups, basically. But it also depends on the interest of the student. I mean, I cannot say that every graduate is going to go to a research team. That really depends on their interest as well. Some of them want to practice more of a, I don't want to say conventional, but more of an architectural practice, so to speak. Not that much of a research agenda, let's say. So they go on to offices that have that kind of opportunity. And other students really go on to join to these research teams. I mean, for example, the head of research in Heatherwick is an MTech graduate right now. So, I mean, or we have a lot of people in Buro Happold, at Zaha, Foster and Partners. So yes, there is that opportunity.
There is a practice context job-wise. Yes. Okay, so curious about that. So let's talk a little bit about the present situation quickly. So roundabout, you were in teaching classes in January, February, and everything's going forward. And then in March, for other studios and other architecture, other architecture schools we mentioned, they said, it was very easy. We got Zoom meetings and, but for you, you're working with materials. So what happened there? What happens to you and your whole laboratory material studies process?
I mean, the thing is, we had to adapt extremely rapidly to the situation. I mean, basically, we had to leave the studio, in a day.
Which was what? Beginning of March?
It was like mid-March. It was 1 week before they started the lockdown here. So we had to immediately leave the school. The thing is, we've been lucky in a way because, our students already started working on their thesis projects by that time. They know each other. They've met physically. So they've been working together. So we adapted pretty quickly to that kind of online platform. Of course, we cannot still access our fabrication labs or robots or anything like that. And we have to obviously follow the government advice. And you know that the UK hasn't been doing very well. I mean, it has been hit very hardly during the COVID epidemic. So right now we are following government advice, and we are going to test the opening up of the fabs, but it will be a test. So It will be like a phased transition.
Right.
I would say it will start
or
in London.
In London.
Okay. Yeah. London. It will most likely be a phased transition, but again, we do not know any specific dates for that as well. In terms of material experimentation, obviously that has been postponed for a while. I mean, some of my students, some of my thesis teams students, they are doing material experiments from home. I mean, you know, there are. Sorry.
Do they have robots at home, or how does that work? To have
no, like simple experiments with sand and binders, and I have one team working with like sand and different kind of like biodegradable binders, for example. So they've been doing some tests at home. Our students are working hard, I must say. They're kind of making the best of the situation that they can. Obviously, it's very also tough on students because right now my students are kind of dispersed over 9 time zones.
Right.
So, yeah, of course. So I have to be in touch with them. They have to be in touch with each other. But they've been going really well. But yeah, I mean, obviously the material side has been a bit postponed for the moment. And as soon as we have access, we'll start again.
Now let's talk about the second aspect of your work, educational, which are these summer programs.
Yes.
The one that you showed, but all the AA has a number of summer. How has that been affected now, and what's happening there?
Yes. That really depends on the let's say the context and the agenda of the program. I would say some summer programs are going forward as online programs. There are a few that I know of that will be on site. So there is one, I think, in Italy that will be actually taking place in Italy on site. But of course, the programs in London are not going to take place. I mean, my programs, the one in Istanbul and London, we made a decision, basically. I mean, we could have done an online course as well. And I'm also doing online courses, by the way, which I think is very important during this time. But the fact that the nature of the courses I run are very much hands-on, I mean, we thought it's better to postpone them to a time when we can all be physically together and, have the same atmosphere and the same, type and quality of work, basically.
The summer programs, we were talking yesterday, when I was in architecture schools back 25 years ago. These kind of summer programs didn't exist, especially these kind of visiting schools and traveling around.
Yeah.
And because of the ease of travel, internet, there's been a increase in summer programs. What do you, just to kind of circle back to that issue, what is the value you think of the summer programs and the summer schools, and why do you think that they've grown so quickly and have become so popular over the last 10 years?
I think I think it's very much to do with experience, the experience that the student or the participant is going to get. For example, I'll give an example from mine, but of course I think that applies to many of the schools of architecture that are running these programs. When students join some of my programs, they get a feel of what they can experience, if they come to the AA or if they come to study in MTech, because we basically run through a very similar workflow, but of course a very kind of condensed one, because it's only 2 to 3 weeks. So obviously it's not going to be the same level of knowledge that you get in 1 year or 16 months, but it will give you an understanding of the kind of the areas that we are interested in, the ways that we work, the interactions that we do, how we collaborate, how we talk to each other. Yeah, it's an introduction. And I think that applies to not just, it's not just about the kind of high-level research agenda, but like I said, it's about the experience. So it's even about how we talk to each other, how we conduct studio sessions, how we run a jury. I think all of these things, contribute to, why a student would want to come and understand, what's going on, because it's really kind of like a short simulation, so to speak, of what goes on in the day.
the ability to do that was in part to do these summer programs, summer schools, can be related to the cost of travel is very low in the European countries.
Yeah.
You had the whole Airbnb. I mean, a lot of this was facilitated by 21st century internet service and provided the services provided tourism, travel, technology, etc. But now there seems to be a questioning of a lot of these things. Of travel, there's a questioning, and there's also questioning of how much, how fast we should be doing. As somebody that's involved in the planning and future projection, do you see these summer programs going back to what they were, or do you see a new normal for that also?
It's difficult to say, I think, right now, because we are still in the situation, we are not post the situation. I think there are two scenarios. I do believe that some of these programs might become more localized. So, different schools might have their own programs that are kind of local, so you wouldn't need to travel that much. But I also still think that people would be interested to travel if they think it's worth it, to be honest. But of course, that depends on the quality of the course and the context of the course. I think that in that case, people would still be willing to travel. I mean, I find it similar to, if you want to, I mean, it's not the same thing, obviously, but, we still want to go for holidays at some point, right? We still want to visit our families or friends. I think it's a similar thing. If you want to have that kind of experience, I think you will still go. But I think at the same time, there will be more localized solutions as well.
So in terms of this COVID and how you adapted, obviously you're focusing on technology. Can you speak a little bit about how the internet and the internet tools and some of the other tools in a collaborative way? Obviously, your students or graduate students, they're used to using some of these technologies. They're used to using some softwares and file sharing and different.
Cloud.
What did you see there? That was there anything in terms of adapting to a very an online digital education? Was there anything that was unexpected, or everybody just kind of flowed into that workflow?
I mean, for the moment, in our case, okay. So first of all, of course, we're learning as we go. So I think that's very important to emphasize. For the moment, I would say that we have adapted pretty fast and well. So, of course, we use Zoom for online meetings. We have like a cloud server where we can share our files, where we distribute files. The AA has extended their online resources quite in a big way, I must say. So there's you can access a lot of different online resources like books, journals, videos. I mean, there's this whole list of resources which I think is quite useful. But also, the way we are kind of evolving it is that we right now currently are looking into recording sessions so that students have a chance to watch them prior to studio sessions, basically.
Right.
So that not everything goes live, but some things are pre-recorded. They can have access to it, they can watch it, and then when we meet online, we can have discussions on it. So we are trying to make the system more efficient, so to speak.
So there's feedback.
Exactly, and I mean this obviously, exactly. You're right. This also goes hand in hand with what the students give us as feedback. So I kind of meet with them regularly, ask them, guys, how did you find this session? Like, do you have feedback? So now we're kind of moving on to both, live and pre-recorded kind of webinars, so that they can get the most of it.
I'm going to keep asking questions, but if anybody on YouTube Live, on right side of the screen, there's a chat window. And if you want to pose a question to Elif, feel free to do that. We have Jonathan Phillips here in the office who's looking through those questions. And he'll sift them out for us. Any questions coming, guys? Any questions there? Not yet. So ask some questions because I can talk. Now let's take it from just talking about the tools to something a little bit more conceptual, which is you're the director of a graduate program in what we call emergent technology, and there's been a lot of activity in the last 20, 30 years with software for architecture and design.
Yeah.
But one of the things I noticed, I mean, just from my own personal history, I was taking architecture classes in the late 80s, early 90s at Columbia, and we had to, there was one technology or two technology classes. One of them you had to go to mainframe and put in like all the points in your three-dimensional model. You had like a command line, so it was all a bit, clunky. But there's always been this kind of move towards using software to kind of just make a three-dimensional model of a real spatial condition, let's say.
Yeah.
Maybe we have some other analytical tools, finite analysis tools, structural analysis tools to give us a little bit more of a nuance in terms of the structure. Well, I want to speak about a potential emergent technology because I think we're starting to get at it a little bit right now, which is what you just talked about, that is digital, but kind of uses the collaborative context that we're in now. I mean, the students, they're very used to using these things, but in terms of the architectural representation, and it's not something that's talked about a lot, using the collaborative potential of the internet, the collaborative potential of data. Do you see, any kind of, let's say, you smell anything in that direction of moving away from this just three-dimensional model to something maybe perhaps more time-oriented, like we spoke yesterday?
Yes, definitely. Well,
my question is, okay, architecture is a thing that you experience in space and time, but a lot of the effort or technology, software in the last 30 years has been focused really on the spatial bit.
Yeah, exactly. Yeah.
Right now we have three-dimensional real-time modeling. We have groups like forensic architecture that's focused on three-dimensional events. But there's yet to seep into architectural design practice. Okay, I go to architectural offices and they're talking with the client around a SketchUp model, right? Everybody's just sketching, moving around and stuff.
Right.
In terms of a design tool, the three-dimensional, model that we have now, is there a chance to take it forward? And right now it's purely speculative I'm talking about, but I'm just wondering on your front, what that is. Is there anything there?
Yeah, I mean, okay, I can think of like from the top of my head, two directions basically. One is I think we also talked about this yesterday, the use of like AR and VR for design as a collaborative tool. So kind of moving away from the kind of like the game engine side of things, but actually using those engines for people to collaborate on making certain design decisions. So for example, as an architect, you can design a space, and then people can enter that space. The users of that space can enter it, and they can give you feedback. So it can become a really nice kind of feedback kind of mechanism or device, or you name it. So I think one direction is that. From another perspective, and this is also part of what we deal with in MTech as well. When you think about the time aspect of the drawing, but not just the drawing itself, the time aspect of the design problem, if you look at problems such as, sea level rise and
environmental
population density, environmental concerns, performance-related concerns, this is not about drawing anymore. This is not just about a single drawing of, an analysis anymore, but This is about, trying to depict or trying to show how, for example, in that neighborhood scale, how that neighborhood can sustain, for example, sea level rise for the next 100 years. So the point is, you shouldn't make a drawing of your current proposal, but you should really make a drawing of what proposal can adapt in the next 50 or 100 years. So I think that brings a very interesting point in terms of, how the design can adapt to time, but also how how that is reflected in the drawing itself, in the architectural drawing. So yeah, I mean, for me, it's really about, in a way, the drawing is related to the design problem, obviously, but the nature of that design problem, the time aspect of the design problem, should be reflected in the drawing somehow, if that makes sense.
Okay. Yeah, and, I think the key bit there is, and the reason I mentioned this question is because we're going through this change, and the change is obviously a technological change, and it's this you're telling us your students are distributed over nine time zones, and you're dealing with all the software. So this is all well and good, and you maintain some degree of educational discipline with regard to what you're doing. And you also said that next term might be something like this also, where it's not, it's not going to be the same thing it was before. Right? I mean, the next term is not going to be like the previous term, in terms of it's not going to be like it was always.
Yeah, I mean, looking at the situation now, but also, these things are changing all the time. So, I mean, the advice is changing all the time. It's adapting constantly. So we have a question.
Okay. Yeah, we have a question from Michelle College. She's asking, in terms of the awareness, integration of the cultural implications and experiences and social relations, and design as site-specific installation, cultural implications in experience and social aspect in terms of these relations. Have you been able to move into that slippery slope of culture and social relations?
Yeah, that is I agree, slippery slope. Okay, no, I think it's a very interesting question, and it's definitely something that we need to consider. Now, first of all, our installations, let's say the prototypes, are mostly, I'm sure you've understood that, they're mostly informed by structural or environmental performance criteria. When it comes to, let's say, cultural experience, I mean, I'll talk about experiences, and social relations. I think that comes in the architectural brief, so to speak. And I think that's definitely something that we should, and we have been starting to consider. And, also it's interesting because, you cannot parameterize everything. So not everything can be quantified. So, the quality of the cultural experience or the social experience, it really also depends on the context and the people experiencing it. I'm not aware, at least from the current, let's say, research, of any kind of quantifiable methods of assessing or evaluating that. I mean, I think that, as this practice of research and prototyping evolves and improves, because I still think it's in the early years in some ways, more kind of architectural considerations or cultural social considerations can be embedded in the brief, in the architectural brief, and how it is, morphologically treated or, structurally treated in every different scale, I would say.
It's interesting, because I think this relates to what you were saying earlier, that, for example, some programs increasingly more localized.
Yes.
There you have this opportunity for this kind of thing.
Yeah.
Okay.
Also, I think one other aspect of, answering this is, these are still very much, these kinds of researches are still very much taken in academia. So I think that as the academia and the business and the building industry start to kind of come together, And as the building industry also starts to understand what the academia is doing, I think that cultural and social aspect will come into play more.
Again, another localization from a ex-student of yours, an architect. He's asking about the techniques and how they can be localized in particular countries like Turkey, who have, let's say, less access. Although I wouldn't say the technology is not there. The technology is there, but the access is not there. So, you've been coming in and out of Turkey. So, what do you feel is the role of these design tools and manufacturing techniques in a place like Turkey, which is where the dots are not necessarily always connected as easily in a place like the UK?
I mean, I think that there is a lot of interest in Turkey. First of all, like you say, the manufacturing techniques are there. I also am aware of a lot of like young researchers, in academia, working with these tools and techniques. I mean, I see in conferences, for example, a lot of papers. So there is a lot of interest. I think it's evolving also rapidly in Turkey. The only difference could be, of course, when you think of it culturally and historically, some of these, techniques and methods, they've started evolving, let's say, more in Western countries, you could say, because of the access to computation, to resources. But I think that, there is a huge interest, growing interest in Turkey. So I see a lot of potential. And I mean, that's also one of the reasons why I've been doing these visiting schools in Turkey for the past 10 years. If there was no interest, I wouldn't need to do it, And I know that other schools of architecture are also doing such programs in Turkey. So there's a lot of interest, clearly.
Yeah, I think the whole, we talked a little bit about the summer programs and effectively on a global scale, but I think it's been one of the successful outreach initiatives of what can be seen as a very elitist system, which is architectural education. I mean,
yes,
it's very removed from a lot of things. And summer programs allowing access to a wider group of students in a wider geography, I think, shows one of the successes of architectural education over the last 10, 15 years. We got another question from Jonathan Phillips, who's our editor here. Jonathan's asking, is it financially effective for architecture firms to have teams doing material research in-house? Whether it's project specific. If not, how can this effort be privatized? He asks.
Right. Okay. So this is a really good question because there are different trends in different parts of the world. For example, in the States, there are consultancies. I mean, there are firms, giving computational consultancies to architectural firms or industrial design firms or so on and so forth. Whereas in the UK, like I said, it's more in-house. Now, I cannot really speak about the financial aspect of it, but what I can speak about is in the UK, the in-house research teams, they mostly do, it's mostly project specific, at least in the beginning. So, you have a project, you want to say rationalize a facade, and you go to the computational team and they start working on it. But of course, as time goes by, all of this knowledge accumulates in the research team, so then they can kind of attach to any project and solve their computational problems or issues or whatever it is. The last question, how does the profession benefit if it is privatized? Well, that's a good question, but I think that question should be directed to the in-house research teams and how they are operated. Basically, I as a person believe that information should be made public, and I believe in open source information. But of course, some offices do not want to share their knowledge or the kind of experience they've generated. But I mean, that can also be understood. I think that in time, as at least I'm optimistic about these things. I believe that in time it will be more and more open source.
I mean, it kind of has to be.
It has to, yeah.
Yeah, I mean, I was discussing the issue with Shulan Kolotan, and within the private practice, if you have architects putting together knowledge, it doesn't make sense to have that knowledge in isolation. We know that when you publish that paper and then somebody gives feedback on that paper. I mean, the scientists have done a really good job. And I think this is where architects and I think it's a good question, Jonathan. Thank you. That, in this day and age, you got to step up with the knowledge you have, and to hide it or to think it's your personal property. It's not going to, it might get you somewhere along the line. But ultimately, you have to think like science, especially in an age of what I can say is crisis. So
I mean, definitely in the long run, it won't get you anywhere. So maybe in the short run, but not in the long run. So it has to be made public.
Okay, we had a question from Defne Gurgulu. She's asking, what are some of the benefits of having a multicultural student experience? Like your students we talked about yesterday, you have students from 9 different time zones, from the east, the west, north, south. And this is one of the reasons people come to the AA, come to your graduate program, is this level of multicultural dialogue. Can you talk a little bit about that and its effects? And do you feel that will continue despite this latest crisis?
Yes. Yes. Okay. That's a really good question as well. Of course, first of all, I should say that all the work that's generated in our studio is team-based. So, you have individuals coming in from all around the world, meeting each other in the first couple of weeks, and then starting to work together right away in teams of 2 or 3 people. And also one other aspect is we have individuals coming from very different backgrounds. So, I have students who have just graduated from university. I have students, who are older than me, who were running their own practice and who wanted to learn something new. So both in terms of, background and age and, cultural background, it's a kind of a complete mixture. Of course, it has its own, I would say, challenges sometimes because people need to get used to working with one another. But I think that, in the long run, I mean, like throughout the entire year, it's mostly always very positive. People learn a lot from each other. People learn a lot from how they work, their individual working habits. They also learn to kind of, how can I put this? You have, like, each individual have their own skills and strengths, right? Or their weaknesses. So they learn how to compensate those in a team environment. So, I might be very skilled in one area. You might be very skilled in a different area. We come together and we learn how to work together, basically. So I think that's really important. And part of the reason why it's also important is because when you go out, when you graduate and when you start to work in an office, it's going to be the same thing. You are going to be part of a team. You will have to be functioning in a team and you will have to, work with people, collaborate, sometimes compensate, listen to people. So I think it's a kind of, again, I will use the same word, but it's kind of a simulation, so to speak, of what's going to happen afterwards, because you need to learn how to respect people, how to listen to people, and how to work together with people. So that's also part of the education. It's not just about architecture.
Right. And which is the kind of reason that people come to schools.
Yes.
Is for this interaction with other students.
Exactly.
We talked a little bit about that yesterday. I mean, if schools are not going to be physical context for learning, then is the value of the school as much as it was if it's full digital? I think this is some of the questions about how we can kind of bridge this physical digital gap in the coming period, which I think will be needed at least in the short medium term. Any other questions? No, I want to ask questions. Ron? No. So we got how much time we have? We have about like 10 minutes left, 5 minutes left. Cool. I'm going to ask I'm going to go back to my complex questioning about the issue of time and environment
Right.
In the architectural representation, right?
Yes.
Which is kind of the subject here in terms of we've been drawing. People have been drawing. Architects or people that are building things have been drawing things and then giving them to other people so that they can build something,
sure.
right?
Yes.
Going on for like a long time, right? It's interesting we're having this similar discussion, Gokhan Avcıoğlu, with Mario Carpo. And one of the things I interjected there is, for example, in the Ottoman world, you can't find many architectural drawings in the Ottoman world. Look around, there's not so many. Why? Because it was a much of a verbal thing,
Exactly.
Well, do this, do that,
Yeah.
Give a specific task, and Sinan comes yesterday and says, "I told you to build it here like this. You built it like this." So, it's kind of social verbal image.
Yes.
And it's based in the process of somebody directing somebody.
Exactly.
But interestingly enough, now
it's completely the opposite.
It's completely opposite.
Yeah, it's so
this thing of this possibility of this time-based three-dimensional representation. Right now, if this thing is existing in software, pretty soon it's going to be existing as hardware, and it'll be existing physically. Yeah. Where a lot of the the sort of more discrete things will be kind of melding together.
Correct.
And I'm not just talking about the end of architecture. Like, you're going to be able to go into Google SketchUp and hit a button, and then next day something comes and then it's going to be completely built. Right? I'm not talking about that. I think that whatever, there's a possibility of that. But in terms of the notion of architecture, and I'm an architectural critic, so it's sort of my mind wanders to, which is this. The architectural object for many, many years has been this physical object that some people would draw and other people build. But today it's a much different object. And this world that we're entering into now suggests a different architectural object. So I want to ask, and you're somebody on the front line of this. What do you see in terms of emergent technologies? You mentioned VR, AR, you mentioned environmental simulation. You see in this perhaps a more central role for architecture, not just as a building discipline, but as a more environmental discipline? Is that what you're seeing?
I'm not saying more of an environmental discipline, but I think what I'm trying to say is a bit about systems thinking. Systems design, architect as a system designer. So it's because, like you say, nowadays we have so many tools that we need to process so much information, so much data. We need to be able to synthesize all this data. We need to be able to understand relationships and, then come up with design methods or design solutions. So, I really think it's about, I read a lot of systems thinking, system theory in the past. And I always kind of reflect back on that. I think that the architect as a system designer is going to be quite important in the future. I also think that, you as an architect, you cannot be an expert in all of these tools, and there is no way and there's no need either. But you need to be able to understand the nature of the data, of the information that you're looking at. You need to be able to understand it.
This is the Mario Carpo argument about the second digital turn, is that the architects have to get their data to this data.
Exactly. Yeah. That's. I don't know if that answers your question.
No, that answers your question. It shows you that. I was having a discussion with John McGilligan. Sorry, he's one of the partners at Rochester.
Yes.
And we were talking about how in the profession now there's been specialization, such as certain offices get theater projects and some get hospital projects.
Exactly.
But this has kind of reduced the impact of systems thinking because it's become much more interface, technology, technique thinking. And it's some of it's been the value of architecture systems thinking since the post-war period. it was that. So I think the return to that is what I think is also good.
Definitely. I mean, maybe it's easy to say, but I mean, like you say, of course, you know, there will be specializations, but you should not be losing like the generalist view of, you know, of the domain that you're operating in. So, you know, obviously, like, you know, I or like my program, we are specialized in one thing, right? Or like several things, but you shouldn't be losing the perspective, let's say.
Right.
And how, you know, you can address architectural problems, but maybe it's just that we all have our own different ways of addressing them.
Right.
And yeah.
Okay. So I think that we're at the end. So I'm just going to ask a last question. There's no other questions, which is what's going to be going on in the AA in September in terms of what's going on with school. You mentioned it a little bit earlier, but
right. Yeah, I mean,
we talked a little bit about perhaps students coming in stages,
yes.
not big classes. So just as a final comment, what's going on in architecture education at AA coming in the fall?
I mean, currently it seems like, and again, like I said before, these rules are changing all the time. But currently it seems like we are going to have a kind of a phase transition, and some of the seminars will be conducted online as now. And it seems like hopefully there will be limited access to the school premises. But yeah, like I mentioned before, it will be in batches. So, you know, everyone will they have their own turn to enter the premises and work and then leave, and then other people coming in, basically. So we will have to find new ways of interacting and, you know, new ways of generating that experience for the students. Yeah, both online and physical, until we go back to a complete normal situation.
Okay. Yeah. So I want to thank Elif Erdine, and just as a
thank
we
you.
did it in English, so kusura bakmayın biz bunu İngilizce yaptık.
Evet.
Olsun. Elif, teşekkürler.
Çok teşekkür ederim. Ben çok teşekkür ederim size.
Thank you very much to Ufuk Durda, who did our technical. It seems over there. There you go. Over there, Ufuk is over there. That's Jonathan Phillips. Poyraz, the GAD Foundation has been involved in global discourse in architecture education. We're doing our discussion today in the GAD offices, which are here. So thank you for the GAD Foundation for the continued support.
Yes, thank you for having me.
And thank you, Elif. And if anybody has any questions for Elif, or email address on AA website, you can send her email whenever you want. You can send me an email whenever you want. And that's it. So thank you very much, Elif, and we look forward to seeing everyone. To speak about
Thank you, GAD Foundation. Thanks.
Thank you very much.
Bye-bye. Çok teşekkürler.